find the study of natural phenomenon starting point of the development of new branch of knowledge. With this beautiful thought of C.V. Raman, I, Ms. Shravani Shirish Kathale from Standard 9, wish you all happy science. Today I am going to show you a small experiment based on volcanic eruption of vinegar, that is acetic acid, and sodium bicarbonate, that is baking soda. Let's have a look at our ingredients. This is sodium bicarbonate, this is vinegar, and this is an empty container in which we are going to have our experiment. Let's start to our experiment. First, we'll add a small amount of baking soda in a container, and next we are going to add our vinegar to have the volcano. As you can see, the volcano is taking place. By this, we get to know that vinegar is an acid and baking soda is a base. When acid reacts with base, the reaction is known as neutralization reaction. When baking soda was placed in vinegar, producing carbon dioxide gas, which evidenced the formation of bubbles with foaming mixture.
Good morning everyone, I am Sushan Bangire from 6th. Today I am going to tell you a small experiment in front of you, that is magnetic material and non-magnetic material. My aim is to tell you whether the object is magnetic material or non-magnetic material. We have some ingredients over here. The ingredients are pins, bits of paper, nails, sawdust, sand, coins, and a magnet. Let's begin. Take some sand in the bowl. Now take pins, bits of paper, nails, sawdust, coins. Now stir it well. Now take a magnet and move around the mixture. Wow! We observe that some objects stick to a magnet and some remains seen in the bowl. That tells us that the material that stick to a magnet is called magnetic material, and the material which does not stick to a magnet is called non-magnetic material. This shows that pins, nails, coins are magnetic material. Bits of paper, sawdust, and sand are non-magnetic material. Thank you.
My name is Prajwal Prashant Joshi. I am from 6th day, roll number 37. Good morning, my dear friends and my teachers. Today we are going to see how the electromagnet works, and we will make one of them. So you need is a copper wire, a battery holder and two batteries, one iron nail and one button. So let's wind it. So our nail is ready. So after doing this, I will now connect it to the battery. So I will connect the red wire here, and this will be connected here. Yes, so after doing this, I will connect this to here. So now let's check that it's working. Now it is not working, but when on this it's working, you can see that now it's working. See, off it goes off. So for testing, we are taking one nut bolt and one nail cutter. So Now you can see that it is not attracting. Not attracting. But now when I on it, it attracts. You can see, and this with nail cutter also it attracts. So the observations are that magnetism is produced in the nail because of the electric current, and when it is put off, the magnetism vanishes. Electromagnets are used when there is a need of a controllable magnet, as they can be switched on and off. The examples of the electromagnet are maglev train, speakers and doorbells, etc. Thank you.
Hello, wish you a very happy Science Day to all. Today we are going to see that how light travels. First, take 3 cardboard papers, then make a hole in each cardboard. Now arrange the cardboards in such a way that the 3 holes are in the same line. Now, place a candle aside the cardboards. Now see the flame of the candle from the holes. We can see the flame of the candle clearly. Now move any one cardboard from its original place and see the flame. We cannot see the flame of the candle because we have studied that light always travels in a straight line, and it is called linear propagation of light. Thus, through this experiment, we can conclude that light always travels in a straight line. Thank you.
Hello everyone, my name is Nitesh Tugeja. Today we are going to do this experiment. In this experiment, we'll prove that light needs a medium to travel. So let's begin. For this experiment, we will need a glass of water, few drops of milk and a laser light. To do this experiment, we will put the laser into the water. As we can see, the ray of light isn't visible into the clear water. So to make the experiment work, we'll put the spoonful of milk inside the glass of water to make the water turbid. Now our water is turbid, and when we use the laser again, we can see the ray of light is clearly visible in the water. Thus, we have proved our point that light needs a medium to travel. By doing this experiment, we can conclude that light needs a medium to travel. In this experiment, the medium was milk particles, but in our day-to-day life, the medium is air particles. Thank you and have a great day.
Everyone, my name is Svarasamir Desai, and the aim of my today's experiment is effect of density. So let's see what ingredients do we need. First of all, we need a glass of normal water, then one more glass which is filled with salty water, then a potato. So let's start with the experiment. So first of all, we'll take the potato and put it in the normal water. As you can see, the potato sinks. So now let's put the potato in the salty water. As you can see, the potato floats. This happens because the density of the water increases as we put salt in it. Thank you.
Greetings to everyone. My name is Sara Sandesh Butala from class 7E. Today, on the occasion of Science Day, I am going to perform an experiment based on the properties of magnetism. I am going to show an experiment of invisible magnetic fields of a magnet. For that, we will keep a bar magnet in the center of the cardboard and keep a paper on it. We will pour some iron filings on it. And see the design. Conclusion: the intensity of a magnetic field is low where the lines of force are scattered, and the intensity is high where the lines of force are concentrated. Thank
Greetings to everyone. My name is Tanvi Maheshingle from Standard 7th A. Today, on the occasion of Science Day, I will be performing an experiment based on the chapter Properties of Magnetism. I will be showing the experiment of temporary magnetism. For that, we will need a magnet and some iron pins. Now, let's start with the experiment. Now I'll take the two pins and try to rub it against each other, but it is not getting attracted. However, when we take the magnet and rub the pin against it and then try to touch it to the other pin, it gets attracted. This shows the property of temporary magnetism.
Hi, I am Samruddhi. Today I am going to present you an experiment on air pressure. We need a bottle, a bowl, a straw and a balloon. So we need a bottle and we have to cut a small hole to put the straw in it. Now we will put the straw in that hole like this. Now we will put the water in this bottle. We will pour 75% of water. We have poured the water in the bottle. Now we will blow the balloon. We will not remove this hand from the balloon, otherwise the water will fall down. Now we will place the tip of the balloon on the top of the bottle. We have placed the balloon on this bottle in this way. Now we will slowly leave the hand so the water will come out from the straw. From this experiment, we all have learned that the air inside the balloon is under higher pressure. When you place the inflated balloon on the top of the bottle, the air pressure on the top of the bottle increases. This pushes down on the water in the balloon, which rises through a straw and comes out making a fountain. Thank you.
Respectful teachers and students, my name is Tanvi Deval and I am from Standard 7th, Division B. Today I am going to perform an experiment on density of water. Here for the experiment, I have taken a bowl full of water, plastic sharpener, eraser, coin, wooden pencil and a plastic cap of bottle. Now we are going to try and put every object in the water and see if it floats or sinks and why. Let's start with the sharpener. The sharpener sinks because as we know that a sharpener has a hole in it. So when the water gets inside it, it starts sinking. Now we are going to put the eraser. The eraser directly sinks in the water because it is heavy object. Now let's put the coin inside the water. Coin is made up of metals and as we know that metals are very heavy. So that's why the coin will always sink in the water as the other metals do. Now we will put the wooden pencil in the water. As we know that wood always floats on water and it is light. That's why the wooden pencil will also float on water. Now it's time for the plastic cap of bottle.
The plastic cap of bottle will always float because it is made up of plastic. Now let's try putting water into it and see if it floats or sinks. Even when the plastic cap of bottle is filled with water, it floats. Just because the
Let us perform an experiment based on the topic Introduction to Acid and Base. After performing this experiment, we'll get an idea about how indicators change their color in the presence of acidic solution and basic solution. To perform this experiment, the materials we need are turmeric indicator. These are domestic indicators which we can make at home using turmeric, water and paper. Then we need a solution of water and detergent, vinegar and lemon juice. Now we'll dip these indicators in each of the solution and identify whether the solution is acidic or basic in nature. So let us first dip this indicator into lemon solution. As you can see, there is no change, which means that lemon juice is acidic in nature. Turmeric paper doesn't change its color in the presence of acid. Now we'll dip this another turmeric paper into solution B, which is our detergent and water. As you can see, after dipping this into the solution of detergent and water, this turmeric paper has changed its color into red, which means that the solution B is basic in nature. Turmeric indicator changes its color in the presence of basic in solution. Now we'll dip this indicator into the third solution, which is vinegar. As you can see, again there is no change, which means that vinegar is again acidic in nature. So this is how we can identify whether the solution is acidic or basic in nature with the help of indicators. Thank you.
Teachers and my dear friends, I am Aditi Chetan Sawant, studying in class 8B. On the occasion of Science Day, I would like to perform an experiment based on sound. The aim of an experiment is to prove that the sound has energy. The requirements are a glass beaker, 2 cell phones, sand, balloon and a scissor. Procedure: take a glass beaker and place it on a table. Take a cell phone and put it inside a glass beaker. Take a rubber band. Take a balloon and cut it. And place it on the open end of the beaker. The stretched balloon acts as a diaphragm. Now place some sand on the diaphragm of the balloon and give a ring to the phone placed inside a beaker and observe. Until we gave observation, until we gave ring to the phone placed inside a beaker, the sand particles remain stationary. When we gave ring to the phone placed inside a beaker, the dancing of sand particles were seen. Thank you.
Morning teachers and my dear friends. My name is Arman Siddiqui and I study in Standard 8 Division B. So today we are conducting an experiment on reflection of light. The aim of our experiment is to demonstrate and understand the laws of reflection. The apparatus used here is a laser pen, a plane mirror and a little bit of talcum powder. So let us start and demonstrate it. So this is a plane mirror and a source of light. As we can see, we can't see the path of light. Now we shall blow the talcum powder. This is the talcum powder. As we see here that the light ray coming from the source of light is getting reflected through the plane mirror. This process is called reflection. Now, the ray of light coming from the source is called incident ray, and the ray which is getting reflected is called reflected ray. And now, if we draw a normal between these two, an angle has been formed. This angle is known as the angle of incidence. And the point where the angle is formed, this point is known as the point of incidence. We also see here that the normal, the incident ray and the reflected ray are on the same surface. We also see that the measure of angle of incidence and angle of reflected is same. Thank you for watching the experiment.
Today we are going to be seeing an experiment based on Newton's third law of motion, the balloon rocket experiment. For this experiment we will need a balloon, a rubber band, scissor, straw, thread and a sellotape. First we are going to inflate the balloon with air and tie it to a rubber band. I already have an inflated balloon tied to a rubber band. Now we are going to put the thread through the straw and attach it to the balloon with the help of sellotape. Now I am going to release the balloon and we will see how it goes. Notice how it goes in that direction whereas the air is in the other direction. As I remove the rubber band from the mouth of the balloon and release the air, my balloon rocket takes off. Notice carefully that the direction of the air coming out of the balloon and the direction of the motion of the rocket are opposite. Here the propelling of the jet air, that is the action from the mouth of the balloon, makes the balloon propagate with an equal force but in the opposite direction, that is the reaction. Newton's third law of motion explains this phenomenon, which is stated as every action has an opposite and equal reaction acting upon it simultaneously. Thank you.
Hello everyone, I am Disha. In this video, we are going to learn about Newton's third law of motion, which states that every action force has an equal and opposite reaction force which acts simultaneously. Have you ever noticed that when people dive off in the diving board, they push down the springboard? The board springs back and pushes them into the air. Why does this happen? Newton's third law of motion explains it. Let's understand Newton's third law of motion as we make our own rocket balloon. For this, we will need a balloon, a riffle, a sellotape, scissors and thread. I have blown this balloon and tied it to the riffle with the help of sellotape. Then I just tied the thread to two corners in the room. And now, when I allow the balloon to release, it will take off. I have done this activity on a large area. Take a look. Notice carefully the direction of air coming out and the direction of motion of the rocket. They are in opposite direction and hence Newton's third law of motion is proved.
Teachers and my dear friends, on this occasion of the Science Day, I, Sarthak Mandalkar, will show you an interesting experiment regarding the reflection of light on how to count the images that are formed by a plane mirror. So friends, the things required for this experiment are a protractor, candle and two large plane mirrors and a cardboard. To do this experiment, we need to place the two mirrors at an angle of 90 degree and then we have to draw its bisectors and keep the candle on the bisectors. We will do the same for the 45-degree angle too. So friends, in case of a 90-degree angle, If we keep a candle on its bisector, we are able to see three images, but there are actually four because two images are coinciding with each other at the center of the mirror.
Today, we are going to understand Newton's first law of motion. The mass of an object decides the inertia of an object, but if applied an external force, it changes its state from rest to motion and from motion to rest. Let us understand this practically. Here we have glass, a piece of cardboard and a plastic ball. First, I place this piece of cardboard on top of the glass. Now, I place this ball exactly at the center. Now, I'll flick this cardboard with the finger. What did we observe? The ball doesn't move along with the cardboard. Instead, it falls straightly into the glass due to gravity. So, we observe that an external force applied on the cardboard threw it away from the glass, but the ball remains in the state of rest. Hence, we conclude that according to the Newton's first law of motion, every object will continue to be in the state of rest or in uniform motion unless an external unbalanced force acts on it.